address or define a constant. What have you done here?
You can load the content and load the address.
Basically, you store this value in the memory somewhere, right?
Yes.
But this one actually doesn't occupy any memory. Okay, so this one is very similar to this in C. You use this in C, right? So for the second option, okay, this for second option, when you define a constant in this way, you are not occupying any memory. The way the program does is, whenever he sees this particular word PNSEL0, he will replace this one with 4002C000. Okay? So the number is not stored to anywhere. Just like your compiler remembered, okay, every time I see this word, I should replace that with that number. Okay, so that's the difference. So, okay, so basically by here, the original value of this register is already in your R1, right? Then, how to do? So they are X curiously, right? And again, these 8 locations, again, they are X. Can be 1, can be 0, can be any pattern. But you want it to be 10, 10, 10, 10, 10 in the end. How to do that? You already know, okay, you already know from the previous question that anything OR with 1, you will get 1. Anything OR with 0, you will get it back. Right? You know this. Any idea?
All and here.
What do you mean by OR and GET?
All first and end with another pattern.
Yeah, firstly correct, you cannot achieve this by one step. You need 2 steps to do this. Okay? So firstly, what you can do is you can clear this range. Clear means I can firstly change this 8-bit to 0, 0, 0, 0, 0, 0, 0, 0. I can firstly do that. And then I can OR with the pattern I want. For example, 1, 0, 1, 0, 1, 0, 1, 0. Okay, if you OR these 2, you can see that your result will be the pattern you want. Right? 0 and 1, you will get 1. 0 and 0, you OR 0 and 0, you get 0. Right? So the pattern will be the pattern you want. Okay? So there are 2 steps. Firstly, you need to clear the bit. Okay? So there is a particular instruction to clear the bit, which is BIC. R1, in this case, R1 is holding the pattern, right? R1 and 0, 0, 0, 0, sorry, 0, 0, AA 0, 0, 0. Sorry, FF 0, 0. FF 0, 0, 0. So how BIC work is, this guy or all this guy result stored in the first argument. Okay? So this value here, whenever you write the 1, the bit at that location will be cleared. That's the way of BIC. Okay, can you see that? This pattern is basically 0, 0, 0, 0, 0, 0, 0, 0, here is 1, 1, 1, 1, 1, 1, 1, 1. These are the particular location here. Okay? So you put 1 here means you want to clear these locations. That's the idea. Okay? So When you do this, after that, okay, originally R1 is holding this, but after this, here will become 0. Okay, that's how BIC works. And now you can do your bitwise OR. Okay, bitwise OR is ORR in ASM. So you do R1, R1, write your pattern here. What should I fill up here?
0, 0.
0, 0, 0. A 0, 0, 0, because A is 1, 0, 1, 0, 1, 0, 1, 0. These are the patterns I want those 8 bits to be. Okay, then you need one more step. So far, what you have done is already happens in this only happens in R1. You are modifying your registers. Yes, you need to store this pattern to the memory location, or to the 4002 location there. Otherwise, it doesn't take any effect. Okay, so you need to do str R1, R2. Okay, so this is for question 2. Now, basically, you know how to write any arbitrary bit at any position, right?
它要 E 才可以 clear， 所以它要放成 E 线。
So this is the
那你0不用 clear 的吗？
answer.
还是 E 所以才要 clear？ 它前面不是 BIC 吗？
没有
Question 3.
0加1的话是1，1加1也是。
Similar, you are doing similar work, but using different method. Okay, so here you is configure the pin function select register to use external interrupt ENT2. Okay, maybe you don't know external interrupt yet, but you need to activate this function. Okay, so to be triggered as incoming pin signal. Do this configuration using C code and this library. Okay, firstly, again, you need to look at the table, see which pin is actually doing this ENT2. Okay, so you can see is here,
0, 1.
right? So, which means you want your P2.12 working in function 0, 1. Right? Again, to do this, you need to basically go to this address, modify the bit, right? I mean, that's actually what's happening inside the processor. Okay, but now you don't need to do so detailed job like this. Okay, because you now can use the library. Okay, so let's look at what we have in the library. Okay, the task now is clear. You need to set this pin to function mode 0, 1. Okay, that is your task.
Clear.
Now, if you look at the function, the library,
就可以 clear 去 0。
okay, the library, you will see this header files. Okay, and one of them is called pin cell. Okay, pin cell.h. There are some functions or structures provided. Okay, so if you look at this header file, you have this structure defined. Okay, you can use it directly. So basically, this is a structure. You all know what structure is, right? In C program. Basically, it's a variable that contains different multiple elements. Okay. For example, in this case, your structure, the name of your structure is pin cell CFG type. Okay, and you have a few elements of this structure. Inside it, you have port number, pin num, func num, pin mode, open drain. You have these elements for this structure. Okay, not only that, if you look at the pin cell.c, Okay, this is again inside your library. It has a function called pin cell config pin. This function, okay, you can read the comments here. Most of the code in the library, there are comments written. Okay, it's a function. The comments is written in front of the function. Okay, so you see this function is to configure pin corresponding to specified parameters passed to the pin config. So this function allows you to configure your pin, directly. You can just configure your pin by calling this function. Okay, so you see inside this, you have set pin function, set register mode, set open drain mode. So basically, if you pass the correct parameter to this function can help you to configure the pin. Okay, but actually what's inside this function is what we did in question 1 and 2. Okay, but in this time you don't need to write those detailed things like go to the memory location, grab all the data by yourself, modify it, put it back. You don't need to do this detailed job. The function is handling that. Okay, so now your question is how to use this function. Okay, so since you have known this, okay, again, this when you run this, is calling another 3 functions at other functions in the library. Okay, and if you trace even deeper, you can see it's actually doing what we did in question 2. Okay, so basically these are the resources you can use directly. You have the structure, you have the function. Okay, and now let's look at this function in detail. What kind of parameter you need to pass into this function? Can you see that here? This is something you need to pass into the function. And this is actually your structure. Can you see that on top? This is actually this structure. So basically you need to pass in a structure with correct elements. Okay, so that you can run this function. Okay, so the way you can do is basically you need to set these elements correct. So remember our task is to set P2.12 to function mode 01. Okay, which means, okay, by the name you know that this is a port number. The first one, port number. So for this particular question, what is your port number?
There's no phone number.
Port number 2, okay? So pin 2.12 means port 2 pin 12. Okay? So in this case, your port number is 2. Your pin number is 12. Your function number is 01. Okay? And these two you can ignore them. So basically we are not talking about that. Okay, you can ignore that. So what you need to do is basically you need to declare your own structure. And that structure should be this type. Okay? This is just like int or float or we say character. These are the type that originally defined by C programming, right? Even you don't write anything, C program recognize this type. But this one is actually the structure type we define because we have this in our library. People who construct this library define this structure type. Okay? So you need to declare a structure variable with this type. You can give any name. Okay? You can give any name. So then you set the element of this structure by writing in this way. So basically, here is the name. Whatever name you write here, you should be here. Okay, consistent.
Yes.
Then structure name dot. This is the element name, right? So basically, let me highlight this. Basically here. Okay, so you are telling this structure. Okay, for this case, your function number is 1, your port number is 2, your pin number is 12, and now you can call this function. Can you see this is okay? Let me use another color. This is a function here. Okay, now you get ready one structure with all the correct parameters. Now you can call this function. Okay, and this function requires
address.
the pointer, right? It's a pointer. It's a pointer pointing to this address. Can you see the star there? It's a pointer pointing to this structure. That's why here you need this and there, right? This refers to address. Okay, I think many of you have forgotten the pointer. Okay, pointer is defined. Okay, when you declare a pointer, you write int star p. This tells that p is a pointer. But once you have declared it, when you write star p again, this is basically get the content. You are getting the content that pointed by p. Okay, but let's say if you have another integer, let's say data. It's a normal number, right? But now you want to get the address of the data, you write and data. This gives you the address, or we say pointer of data. Okay? So it's a quick review of C programming's pointer. Okay, that's why here we want the address of the structure. That's why we put an and in front. Okay? So basically now this is your answer. You just need to write this. It basically does whatever you wrote for question 2. Okay? So later on in your lab, you are at this level. You are at higher level. You don't need to go into the address. Okay? Any questions so far? And let's use this as an example. So P2.12, as I mentioned, each pin is actually can work at 4 different functions, right? So if I draw it here, this is my pin P2.12. You can consider there's a multiplexer that you can work as different functions by this control bits. Okay? So your control has 2 bits because you have totally 4 functions, right? So basically these are your PINSELX bits, right? 00 refers to GPIO, 01 refers to another function, 10 another function, 11 is another function, right? So for PIO 2.12, basically we choose GPIO function. Okay? But for GPIO interface, it has some other registers to configure the GPIO. Okay? So I just put the table here. Again, this table, again, in that file, okay, 800 page files. So here, these are the registers used for GPIO. Okay, so I will explain this by using the next question here. But basically, these registers are actually for 3 types. Okay, we have many registers, but we can conclude them as 3 different types. One is we say status registers. Okay, status registers. Basically, you can get the status of your pin by reading this register. Okay, if let's say you set your P2.12 to be GPIO. Okay, you did this setting, but later on, when you want to know what's the status at this particular pin, you don't read. I mean, you cannot read from that pin directly. You are reading the status from the status registers. That's why the type is RO, read only. Read only. Okay? And there's another register, control register. Okay, for example, you want to set that pin to output or input. Okay? Or you want, the way you want to control the pin, you set the control by writing into control registers. Okay, and another type is data register. You can do both write or read. Okay, you can have a better understanding when we finish the next question. Okay. Okay, so maybe okay, so I explained the registers here. So remember here you have FIO, you have FIO DIR, FIO mask, FIO PIN, FIO set, FIO clear. Okay, so I'm going to explain how this works. For example, FIO DIR. Okay, so I have X here because this register, basically, you have multiple of these registers. For example, FIO0 DIR and FIO1 DIR and so on. Because you have many pins, you have a lot of pins. Okay, so that's why here I put X. Okay, so for FIO DIR, again, is a 32-bit register. And let's say now we want to configure the pin 0.7 to be input. If we want to do this, okay, we cannot control that pin directly. Okay, we control the pin by modify this register. Okay. So let's say we want to configure P0.7. You need to go to the register FIO0 DIR. So the number here and here should be consistent. Okay, so FIO0 DIR is configuring port 0. FIO1 DIR is configuring port 1. And so on. Okay, and since you are talking about pin 7, that's why I need to modify bit 7. Okay, and if you write 1 to this location, if you write 1 here, basically you set the pin as output. If you write 0 here, basically you are setting the pin as input. This is how to use FIO DIR. Get the idea? Basically you are writing to this register. Okay? You are writing to this register. So it's a control register. It's a control register. That's why here you can only do write only. You can only write to it. Okay? So this is write only. Next register, FIO set. Okay, by the name you can tell, if you want to set particular pin, As I mentioned in digital design, when you say set, means you want it to be 1. Okay? So let's say at this moment, okay, we have set, let's say we want to set P2.10. We want to set this pin to be 1. Okay? How we do is we go to FIO2 set, because at this moment we are talking about port 2. Okay? And since we are talking about pin 10, you need to go to bit 10. And if you write 1 here, you are setting this pin. Okay? So the signal outputting from this pin now is giving signal 1. Okay? So that's where you set. But if you put 0 here, you are not making any effect. Okay, pay attention here. When you put 0 here, you are not changing anything. If previously the pin is already outputting 1, it's still outputting 1. You are not changing anything, okay? Because you are in set register, okay? So what if I want this pin to output 0, not 1? You need to go to the clear register, okay? So you need to go to FIO2 CLR bit 0 location. Write 1 here. You are clearing the pin. Okay, so if you write 1 here, P2.10 is actually outputting 0. That's why we call this register clear register. Okay, so basically we are controlling this single pin by multiple registers. If you want to output 1, you need to go to the set register, change something. But if you want this one to output 0, you need to go to 0 register. Clear register. Okay, so we have 2 different registers to set or clear the same pin. Okay? And there's another register. So basically, so far, all these 3 are control registers. You can only write to it. Okay? And the next one, FIOX pin. Okay? This one is data register. So means you can either write or read from it. Okay? So so there are a few cases. Let's say just now we have set or 2. Let's say this one is output because just now we are trying to output 1 or 0 from this pin, right? So let's say your P2.10 now is an output. Okay? And you go to the register FIO2 pin and then look at bit 10. Okay? If you find, now you are reading it, okay? You are reading a register. So if you realize that this location is 1, it tells you that at this moment, this pin is outputting 1. Okay? So previous one here, when you do set, basically you want that pin to output 1. It may not output 1. No. So you want to check whether that pin is really outputting 1. You check from here. You check from FIO pin register. Okay? So if you realize this location is 1, it's not outputting 1. If you realize this bit now is 0, it's basically outputting 0. So this is to check the status of your pin. But if your pin is an input, basically when you see here, you are see the data coming in because now the pin is an input. Okay? pin is input. You monitor the bit. You monitor the values at a particular location to know which data is coming in from that pin, because that pin is the input. Okay, so basically this register allow you to check the status of your pin. Okay, and another register, mask. So let's say you want to do this. Okay, you want to do the set or clear using the previous registers. You can mask a few bits. Let's say later on, a few pins never get used, and you don't want to touch those pins. You want to remain them. You don't want to change the pin because of your program. Okay, because sometimes you may accidentally write something and you change some locations that you actually don't want to change. Okay, to prevent that accident, you can set something in your mask register. So at a certain location, let's say FIO1.8, let's say P1.8, you don't want to touch this pin. So this is something that you never want to touch accidentally. What you can do is you go to FIO1 mask and the bit 8 location, you set this location, this particular bit, to 1. So basically means you give a mask to this particular pin. So later on, whenever you do write clear set, this pin will not get affected. Okay? So if it's 0, you have the freedom to write or set or read or clear. Okay? So this is the registers. So okay, so maybe let's continue. Okay, maybe let me finish this one. So as I mentioned, you have 3 libraries. Okay, you have three libraries. So here is just give you a general idea, like which library is doing what kind of job. Okay, so at the very, very bottom, maybe I should draw this in the other way around. But basically, fundamentally, we have the pins that we want to control or we want to read, right? So at that level, that's why you have this kind of table. Okay, so that is the very, very bottom level, basically. The pins can work at different mode, and you get information or you send out information through these pins. Okay, so that's a very, very bottom level. And then we have a higher level that we create the standard. Okay, for example, we define the structures that enable the mapping, just like your question 1. Okay, so question 1, you have the registers. You have the pin cell registers that you can control the bit. Okay, you can control the bit. And then you have another higher level. Okay, so basically this level, okay, previously the create standard level, we are basically achieved by this library. So this is among the 3 libraries, this is the bottom one. This is the one that's doing all the detailed jobs. Okay, so this is the bottom one. And then you have a higher level, okay, which allow you to access or control the peripherals by controlling the registers or GPIO registers, the one I just introduced last slides. Okay, so this one is actually achieved by using this library, just like our question 3. Okay, remember question 3? We can use the structure that predefined in the library, right? We can use a function which can do the pin cell for us. We call that function directly. Okay, so that is one level higher. So basically achieved by this library MCU. And you have one layer up. You can work on device. Okay, means for example at this moment we do, let's say, LED light sensor. So the light sensor on your board, okay, it actually has multiple pins. It has multiple pins. So you are using multiple pins on your microprocessor to control the light sensor, not only one of them. Okay, so push button is the simplest one. SW4, only one pin, you can control that. I mean, you can detect that whether people is pressing or not pressing. But for complicated devices, such like light sensor or LEDs, 7 segments, right? You have multiple pins. So it will be very difficult for us to control it by like programming each individual pins. That's why there's another library, EA base bar. Okay, so this provides, if you see the source file or the header file, you can see, for example, acc.c, acc.h. So basically, inside these two files, some functions are provided for you to control the accelerometer directly. For example, you can like read accelerometer. So basically, the function will return you some values, telling you the orientation of your board already. But what's happening at the bottom is basically your processor is reading data from multiple pins. Okay, but for your case, when you are doing your assignment tool, we don't need to go into that deeper. We look at device level. Okay, maybe one level down, like the interface level. Okay, for example, GPIO or I2C. Okay, so you are roughly here. You don't need to go into that deeper to do the programming. Okay, so that's the idea. Okay, so I think I stop here. So week 7 we will continue.
I have one question. About the pin. I mean the pin value. Can I put at the output register and write the value to the pin?
You mean this one?
Yeah, correct. FIO X pin. When it's configured at the output, then I write value to the FIO X pin.
You cannot, I mean, if it's an output, you cannot, I don't think you can write to it.
Yeah, because I saw this one in lecture notes. So illustrating that I'm able to write values to FIO pin.
You can, yeah, here. So if it's output, here, okay, let me use another color, this one. If it's output, you can modify them. You can modify the pin from this register. So basically, if you modify this register, what it does is basically do this or this, depending on whether you are writing 0 or 1.
Okay. Yeah. If I write 0, it will be clear, right?
Yes.
Oh, okay.
Okay, this may take some time to understand. I know some people may ask why we do so troublesome way to control or read our bits, because sometimes this is necessary. Okay, you need multiple registers to do the reading. Later on, you will know when you are writing your program. Okay, so I hope to see you all in the lab week 7. Okay.
他说全部上完了。 他的全部上完了吗？
难道没有了吗？后面没有，还有的吧？
几题？
啊，哦，你在这里多人啊？